Hello, I'm Robert, helping you if you're scared of many things with fact-checking. Welcome to my channel. And this time it's about this news story where saying that the pledges so far are inadequate and it's been described as a red alert or something. Isn't any red alert level. And what is not explained, or not put in the headlines at least, is that most of the world's emissions, they haven't submitted their pledges for 2021. The reason it should have been 2020, but the reason it was delayed is not because they didn't submit pledges. The reason it was delayed was because of the pandemic. The event was going to be held in Glasgow, in Scotland, where I live. I don't live in Glasgow, but in my country, the country I live in. And that was at the time that we had the rising cases in the United Kingdom. We had lockdown. It just became clear that it was not going to be easy to host. And this was in the spring, and then there were some people saying, well, we will have got over this by the autumn, but others were saying, no, we can't guarantee that. And so they just had to postpone the COP26 through to 2021, which is when the pledges will be submitted. It was just a kind of Zoom conference in 2020 because it just wasn't practical to hold it in Glasgow. Indeed, in any country it would be quite difficult to hold it because nearly everything is being done via Zoom nowadays because of the pandemic. So some countries have submitted early. Indeed, some countries submitted 2017 and quite several years ago. But most countries, and it's no surprise, haven't done their pledges yet, and they will come in later on in 2021. The EU has given its pledge, so that's quite a significant one. This one separates them out as different countries, I think. But the EU as a unit of all, so like Germany has given its pledge as part of the EU. Italy, France, they are all counted as they've done their pledges. And Japan has done its pledge. So has South Korea. But these ones haven't done their pledges. So China, the biggest emitter of all, the United States, India, Iran, Saudi Arabia, all those ones I've circled, they haven't yet done their pledges. And this total is at least 60% of emissions, along with quite a few in there as well. In total, there are I think 98 countries that are discussing zero emission pledges by 2021. So this is the yes, that's the background. Let's go up to the top. So this is an example of what I'm doing here is positive framing. That I'm explaining that the UN report that has just hit the news, it's about the pledges received so far, and based on the pledges we've received so far, it's really rather good. So with the unconditional and any finance, they see a peak, and this is the previous projections, that one, light blue, and the dark blue is what they see which is unconditional. So they definitely see it coming down, and a likely peak. At the low emissions, you'll also be a peak at the high emissions too, for that matter, well before 2030. And then in the ones that are conditional on any financing, then they see it coming possibly down quite a long way. By 2030, it could drop down like as far as that. Indeed it would. So the conditional means it's conditional on finance. So you may have heard of the Green Climate Fund. And I know the US is planning to work on that, for sure. It just makes sense. So if you are in one of the wealthier countries, one of the most effective ways of reducing global emissions for least cost is to sponsor emission reductions in another country that has got one of these conditional pledges. Choose somewhere like Bangladesh, one of the African countries, somewhere that has got, and just give them finance for example, the Green Fund is already up and running, and for instance, it is used to produce example kickstart, for instance, in India, then renewables, doing an early projects, example projects. It's not a case of paying for all the renewables, they do it by seed funding, where you do an example project to show to people there how it's done, and then they copy it. And generally it's done with a lot of leverage, that you put in a certain amount of funding and then it unlocks a huge amount more of funding as people begin to see that renewables actually work. Because it's very difficult for businessmen in, say, India to put a lot of finance into something that they might just lose it, because they're not very convinced it's going to work. So this conditional finance, then the and then they've got you get a lot more for your money in one of these countries as well. So if you are in the United Kingdom, say, or United States, $1 billion will go much further if you are funding, helping with one of these conditional pledges, than if you use it in your own country. So it actually makes economic sense if your actual aim is to reduce global greenhouse emissions. And these countries, they just don't have the technology. It's also technological assistance. They don't have the industries, they don't have the technology, they don't have the finance easily available, especially private finance is very difficult to unlock, because many people don't have much way of savings. And so the more developed countries, they can do a lot by this condition, by helping them achieve their conditional NDCs and nationally determined contributions. And so this shows the difference between that and that, really pretty huge difference as to what could happen by 2030 with just a small fraction of the funding they're doing for their own greenhouse reductions, to use it to finance reductions in other parts of the world. And that's what the Green Climate Fund is about. It's also about resilience, for instance with Bangladesh dealing with problems of flooding. And they can, if you build in resilience, then you get less refugees. So that helps with their economies, it helps with the problem of migrants, which can affect other countries. So again, it makes a lot of economic sense just from their own self-interest for the wealthy countries to help the poorer, weaker economies to build in resilience to climate change. For instance, you are helping with making sure they have enough water for irrigation and for drinking water, and so they don't have famines, they don't have to move to another part of their country because it's no longer able to farm in the way that they want to. Just makes sense. So I'm not sure. I'll bring up the Green Climate Fund. I haven't got anything on the Green Climate Fund here, so I'll bring it up and I'll give you an idea of some of the projects that they're actually funding just now. Okay, so here's the Green Climate Fund, which as you can see is well underway. It's got 56 adaptation projects, 35. So adaptation is like building in resilience. Mitigation is like helping projects that reduce the CO2 emissions. I'm not sure what cross-cutting projects here are, we'll find out in a minute. So climate change mitigation seeks to reduce the release of greenhouse gases or to increase the capacity of carbon sinks. So it could be improve the efficiency of buildings and appliances, cleaner source of energy such as solar and wind, more efficient and sustainable transportation, or improved use of land and reforestation. Then you've got the climate change adaptation. That's about the impacts on, for instance, water-related disasters such as droughts, floods, storm surges, heat waves and wildfires, to help countries to adapt to these. And the health, livelihoods and lives of billions of people and their children and grandchildren are at risk, and large numbers are at risk of losing their homes in climate-related disasters. And as I said, this affects the entire world. And so these projects and they're for the most vulnerable people and communities, the health and well-being, food and water security, infrastructure and built environment, ecosystems and ecosystem services. And they're monitored in those 4 categories. Then cross-cutting projects is kind of obvious. It's ones that do both. For instance, forest management will both increase the forest carbon sink capacity and also provide a more stable water supply. That's an effect of maintaining a forest. It helps keep the rivers flowing. Indeed, if you've got areas that have lost their forest, the rivers dry up. You let the forests grow back again, or you plant them, and the rivers start to flow again. And then gives them more stable water supply and additional livelihoods. So that's what they do. And I'll put a link to this in the article. I haven't got it anymore in it yet, so you can see what these people are doing. Now I'll just go back to the article. So now again, if you use positive framing, our situation is actually good. And here we are. I've already talked about this before, so I won't do a long video about it, but just to say that according to Carbon Action Tracker, and they're doing basically the same thing as these people are doing, except they've taken account of the statements of intent from US and China, and they say that with those, we're headed for 2.1 degrees centigrade already. The optimistic targets include the statements of intent, which we will get changed into pledges as 2021 continues. So we're already a long way down. It wasn't so long ago, just a year or two ago, we were at 3 degrees, and then before that we were at 4 degrees. So we're just coming down, down, down. Now we're nearly at 2 degrees. And every half degree counts. So don't think that nothing has changed until you reach 1.5 C. Far from it. Every half degree reduction has hugely improved our situation for the rest of this century. And we're now down at 2 degrees C. Now, the most at risk between 2 degrees C, or we will be by the end of 2021. So the most at risk at 2 degrees C are the corals. The Amazon risk comes more at 3 degrees C. And most of the other things happen about 3 degrees C to 4 degrees C. So we've already avoided those. And so that's really quite something very positive we've done. And people just don't explain that. And that again is the positive framing. It's giving the framework, the positive framework of what we've already achieved. In just 5 years, we've gone from somewhere in there all the way down to there. Somewhere in that red zone, all the way down to the yellow zone. Just short of the yellow zone in just 5 years of change. You would never have believed that in 2015. And so the aim was we go, and then in 2015, they didn't know if some countries were saying 2C, some were saying 1.5C. was no consensus around 1.5C. It was mainly like the very low-lying island states in the Pacific because of the risk of flooding, and they were saying 1.5C. There weren't many others saying 1.5C in 2015. And it's really the 2018 report is when this turned around. We started getting everyone saying to 1.5C. It's now got to the point where I don't think there's anyone who's really seriously saying we should aim for 2C. And that's the result of the 2018 report. But it really said that every half degree counted. It didn't say that something happens at 1.5 degrees C. Gradually, as you go up towards 2 degrees C, there's more and more risk of the corals. And they're the most at risk at that point. There are other things like more storms, more droughts, more flooding, and there's a bit more of everything at 2 degrees C, but we've saved an awful lot compared with 3 degrees C. So now, yes, I did explain that. So yes, just as some of the, yes, I've already explained all that. Oh yes, so the main thing is that they did say that the emission, I've explained that, is going to peak before 2030. They said that based on the pledges so far, we're tracked to peak emissions before 2030. So that is as a result of the new pledges. Before then, we didn't know that it was going to peak. And as a result of the new pledges, we now have a clarity it is going to peak. And that's not including China or the United States. And they explain that it's going to change. And they also, with the reports that they've come in, they have found that the pledges that have come in so far, then there's been an issue with shorter term emissions. So generally they do pledge to reach very low emissions by 2050. And they will be within the range implied by either 2 degrees centigrade or 1.5 degrees C with a very low overshoot. In other words, it goes a little bit over 1.5 degrees C. And so below, either in the 2 degrees C or 1.5 C, the low overshoot to maybe 2 degrees C and then comes down again. And so the main issue they found with the pledges they've received so far, this is just for the pledges they've received so far, I think. The main ambition, that was a little bit ambiguous. Anyway, the main issue is that with a shorter term ambition to reduce emissions rapidly by 2030. So they're seeing countries, and that's the same in the UK where I am, then we have this pledge to reach zero emissions by 2050. The government has not yet been very clear about what's going to happen in the nearer term. I can't remember if they've given a target for 2030 yet for the amount of emission. I think they have. Again, or maybe I should just check that as well. Yes, the UK, they've set a very ambitious target, 68% reduction by the end of the decade compared to 1990 to 1990 levels. So we are the ones who are, for us, then we've got this really very low reduction by 2030. Although it would be reasonable to have even lower reduction than that, but that's a decent ambition for a developed country. And the UK is putting forward a particularly strong stance. We may have been influenced because we are actually hosting it for 2026. So as the host, we want to put forward a strong target, and so then we can encourage others to follow the same ambition. Now, the United Kingdom has a history here. Maggie Thatcher was the first leader to bring attention to bring attention to the problem of climate change in the late 1980s. So we have had a leader since 1980, late 1980s. We have been quite strong on climate change, and that we, at least in saying something needs to be done urgently, even though it's only been recently that we've actually developed very strong pledges ourselves. But we do have that history. So yeah, I talked about pledges not included yet. And then these are all the ones who are contemplating zero pledges. I can bring that up in a moment. So what else? Oh yeah, so I was explaining that the Paris Agreement has the pledges increase in ambition every 5 years. And so it would be actually quite a surprise if we actually are already targeting at 45% globally by 2021. So please, if at the end of 2021 we get the announcement, say that it's a 10% reduction or a 20% reduction, then both of those will be good. We don't need to be targeting a 45% reduction globally. So that would be a mix of many countries actually saying much more ambitious targets. Like we've already got 68% for the UK, 45 to 50% probably for the US, so they haven't given a figure yet, and they might even do a lower target than that, faster reduction. Now, an important thing to bear in mind is part of the reason why it's feasible for the UK and for other countries to set these very ambitious targets now is because of the very fast improvements in renewables. And this shows the reduction in price of in costs in US dollars per kilowatt hour for various kinds of renewables. I'll just bring that up. And let's look at this one. This is the zero carbon. These are the ones who are considering zero emissions by 2050. The green ones, then they actually have measures, and then you can look here at the different, some covers all greenhouse gases, excludes international offsets and so on, these various ideas, interim target. So this is about France, for instance, whichever one you click on. So you can click on this map. And it gives, if you click on the States, if you go to the States, for instance, oh yes, I got it the wrong way around. So you can uncheck them all and just show those black ones are all the cities that have these targets, zero by 2050. If you can click that, it goes to net zero by 2050, which excludes a few people. So all of these are net zero by 2050. And these are particular states, like Scotland is a separate, is separate from the rest of the United Kingdom. We have a slightly more ambitious target. So because it's just looking at states rather than countries, and it's bringing up it's classifying Scotland as a kind of a state, I suppose. It has a different target from the rest. So you can see that quite a few US states already have. So it's California. Bring this up a bit. The 2045 covers all greenhouse gases. It doesn't exclude offsets. So you can go and look at that. Nevada 2050, Washington State 2050, Michigan 2050, New York State 2050, Maine 2045, and Louisiana 2050. So these are all states that 1, 2, 3, 4, 5, 6, and then there's this one, Montana 2050, but this is at an earlier stage. It's in policy document. The green ones are more advanced. So eventually the entire US is going to go for this, but we already have several states that have already made these policies. And then if you go and look at Australia, I have to get my thing out of the way, then you have the individual states are much more committed than the federal government. Victoria, and then the other ones will be in policy document. That's actually in law. The green ones have it in law. And then we also have Catalonia, has it in law 2050. So you can click around on this map and then get an idea. We know that some of these countries, if you go and look at the actual countries that are already, and this is the status already, so then it is kept up to date. Look, it's got the United States, the entire thing, it's in policy document. That means, it's an earlier stage. I'm not even sure there's how much of a document there is yet, but we know it's going to come. And then the same thing in China, and that is a 2060 net zero. So those are the ones that are yet to come, and then lots of others you can see it yet to come. And look at these ones, it's a target under discussion. You can see lots of African countries have its target under discussion. Mexico has a target under discussion for 2050. So Mexico, for instance, might produce that as an actual pledge. It's discussing it at the moment. And so you can look here and get an idea of all the countries that make Afghanistan. Pakistan is a target under discussion. Italy, Romania. I'm not quite sure, since the EU has already adopted it, I'm not quite sure why they have Italy as separate. And maybe it just means that they haven't implemented the EU law. I'm not quite sure I understand that. Finland, 2035. So Finland has it in policy document, and this is one of the earliest ones. One of the quick fastest ones of the major economies. Some of them, like Suriname, has already achieved it. So also as Bhutan, if I can find it. Is that Bhutan? Yes, Bhutan has already achieved it. That's because these two countries are already carbon negative. Suriname particularly, is hugely carbon negative. This is based on using because their forest is taking up so much CO2 from the atmosphere, and compared with the actual emissions, and they've also got a reasonable amount of renewables in it, and their forest is taking up a lot of emissions. So if you do the offsetting, if you count the forest and the effect of maintaining the forest in good condition, there we are. That's South Korea proposed legislation, and then we have here Canada proposed legislation. With Canada, then you do know there's a difficulty of it's sort of back to opposite from Australia. In Australia, the individual states are going for 2050. The federal government is the one that's dragging its heels. In Canada, it's the other way around. The federal government wants 2050, and then the states are dragging their wheels. So both of those have some issues. Anyway, so that's the situation, and you can see that there's plenty of room for more. It's not just China and the United States. There are quite a few other countries that have the possibility, like Mexico, for instance, that may well join in and have zero emissions. And let's look at that. So this was about the really astonishing reduction in the prices of renewables in just since 2015 even, and especially that yellow one, and a tenfold reduction in a decade, I think it is. Tenfold fall in price of solar panels in 10 years. And I think even since 2015, then it's gone from 0.15 all the way down to, it's more than a threefold reduction in just the last 5 years in the price of solar panels. And this has got to the point where wind and solar are actually competitive with gas-fired electricity, and by 2025 gas-fired electricity, which is about the lowest cost fossil fuels, is expected to cost twice as much as onshore wind or solar. So by 2025, so we are doing these emissions. Now they can't actually assume that, so we can't make a pledge yet based on that. And so this is what I was going to explaining here, that the way it works is that the reductions get easier as the technology improves. And then that actual article was about perovskite, and perovskite is already underway as a potential. There's a whole lot of thing about it. It's already underway as a potential. Is that I really go for graphs, but anyway, this is a projection for reduction in the, for projection for 2035 in the cost of solar PV panels, but that could be really very radically reduced. It could halve in price just about there already if perovskite comes out. If the perovskite thing works. So we have this possibility of real game changers. It could make a huge difference. But you can't count on them until they happen. The perovskite is doing pretty well. Perovskite is solar panels that you can basically you can print them almost like an inkjet printer. So if you can print them out. Oh, I can't remember. You just paint them out basically. You don't need to use. The main thing is you don't need to do them in vacuum conditions. You can make them at ordinary room pressure. And so this makes it technologically much easier. And many countries will have that capability to make perovskite panels. And then perovskite panels are also flexible. And so they're much easier to transport around. And so it's practical that we have perovskite panels, and they are being produced in China at kind of pilot industrial level. And so it is possible that by the early 2020s, mid-2020s, that's what solar panels are. And that you are much easier to install, and you can actually sort of just spread them out in a desert or on a roof in sub-Saharan Africa, and they'll immediately have electricity in the daytime. So that could be quite a game changer if that works out. And another example like that is we are going to have short haul flights of electric planes. That is definitely going to happen in the early 2020s. Before 2025, it'll probably be quite common to be travelling on an electric plane if you want to just travel a few hundred miles instead of a few thousand miles. If it 10, 50, 100 miles, I'm not sure that sort of a distance, you'll be hopping around the United States on electric planes, and they are lower cost, so more people would use them. They are very fuel efficient. They are lower cost than conventional planes. Electricity uses much less power. It's much less of actual. They can be made more efficient. So that's a game changer that's going to be happening. We've got electric cars, and then for the complete transition to zero emissions by 2050, then eventually we have to do something about transport. And Norway is just going ahead, and it already has lots of electric cars, but the electric cars, there's a premium at the moment. They cost a little bit more than non-electric, and that's going to change. And then there's the problem of the mileage for electric cars. They still don't quite have the range of a car that runs gas, or petrol as we call it in the United Kingdom. And that is going to change as batteries get better and better, so you get more mileage from your electric car. So the transition, since cars get changed naturally, it's about 15 years average to replacement time for a car, then it goes on a scrap heap, then it gets recycled, a lot of it into new cars again. So and the solar panels, they get recycled into new solar panels. And so there's actually a requirement nowadays, for instance in the EU, that you have to make sure that solar panels are a very high percentage recyclable. Anyway, so cars get recycled typically on a timescale of about 15 years. So that means that for zero emissions by 2050, you've got until 2035 to get to the point where all the new cars are electric. And to achieve that, then we could just do a huge, very expensive change all cars to electric right now. But it actually makes more sense in many ways to wait until, say, 2030 or so before we do the transition to electric cars. And it doesn't mean no petrol-driven cars, but it would gradually be that there are no new electric cars. Of course, vintage cars, for instance, then you can't just say nobody can actually drive around in a vintage car. Although, I mean, I suppose eventually, maybe, but I don't know what's going to happen with vintage cars. But for sure, they'll be able to drive around in them, maybe on special occasions and so on. I'm looking very far future. Sorry, I shouldn't go off script, as it were. I have written a thing about petrol cars and what happens to petrol cars when you transition to electric cars, but I can't remember what the details of it now. Yeah, I better bring that up. Sorry, I shouldn't have. I'm sorry, that was about self-driving cars. And so people are worried that in the future we might just only be able to drive in self-driving cars. I think that's actually very unlikely. But and then self-driving cars will probably, if it does come that, will have a mode where you can drive the car yourself. If the self-driving autonomy, but the self-driving autonomy would take over if you do something very dangerous. But this is assuming that it ever even works, because at the moment it's a science fiction. Self-driving cars. I know that there's lots of the cars with self-driving mode, but purely self-driving cars, it's not yet here yet. There's an awful lot to be done yet before they can prove they're safe. But anyway, sorry, that was distraction. So that wasn't what I was talking about. So anyway, what I was saying was that if we have gas-driven cars, and then eventually the normal way they do it is that they make it so that you only have to that all the electric cars, new cars being sold, have to be electric. But for the time being, in the United States, and that's already happening in Norway, and they're on their way there, but in the United States, it's going to be more efficiency. That new cars have to be very efficient, and so you get more mileage for your gallon. And then gradually get to the point where the new cars have to be electric. Maybe 2030s, they haven't said a time for that. But you would still be able to have your gas-driven car. And then if eventually it was to become an issue even with a gas-driven car, that would probably be because of issues of pollution from the gas and the smell of the petrol and so on. But I think that would be quite a long way in the future if that does happen. I'm sure we're still going to have gas-driven cars for a very long time. And always, if it's off-road, obviously. And just like probably be adaptations to make your car roadworthy for the new standards. But we're looking at very, very far future here. But that's not what, they're not going to make gas-driven cars illegal. That's not the normal way that countries are doing this. And what they do is they make it so that the electric cars are the ones that they have lots of incentives to buy electric. They have buyback incentives so that people who have a gas-driven car, then they have these incentives to sell it to the government so that they can for a replacement. That is if they want to do it very quickly. But we can manage fine with a slow transition, because it's all right if cars are the last to reach zero emissions. Sometime around 2050 though, then there should be almost no gas-driven cars left on the roads. But as I said, there surely would be vintage enthusiasts, just like the people with penny farthings, and maybe there would be some special allowances for them to permit them to drive around and offset their emissions or something. But we're looking very far in the future, and we're talking about 30 years from now before we have to hit something like that. Right, so have I said everything here? So, so I was just saying, so the pledges will increase in 2025. Yes, I haven't really explained this, sorry. So, it's kind of obvious that these, if you go up to this figure here, then the numbers, this thing here, then let's just bring up this diagram again. So that's what this looks like now. By 2021 pledges, and that will surely be reduced, but probably not all the way down to the reduction that we wanted to have. All the way down to half of that even. So I'm not sure it's reduction. Since it's a very steep reduction to the UK is going to reduce it to 1990 levels. This is strange. Greenhouse gas emissions. Why do we have such a big reduction in 1995? Oh, it's one of these things. Oh, it's rather misleading. Yes, that is much less of a reduction than it looks like, because they aren't starting the access at 0. Sorry, I should have called out on that, but I didn't even notice. So this is, as you can see, it's just a few percent reduction, which is, I was wondering, it didn't seem really quite to fit with the statement, but so it starts at 12 there. So it's just little wiggles. So that's something to bear in mind. So it could easily be that it's going way down like that by the time we've got into our mind, by the time we've got the UK, got the United States and the China pledges and all those other countries. It could be way down a fair bit anyway. But for the 50% reduction by 2045, it doesn't matter if we don't achieve that in 2020, because we could then have a much better situation in 2025, where we have renewables half the cost of the lowest cost fossil fuels, and that will make it much easier for countries to make very ambitious plans in 2025, which they can't do now. And then if that still hasn't done it, then by 2030, say we are at, say, 30% reduction by 2030, so we've rather done overshoot, then what this doesn't explain, it almost gives the impression that if we aren't at 45% reduction in 2030, then we've lost our chance to stay below 1.5 degrees C. That's not true. So if we are sort of like 30% reduction at 2030, that means we've got to reduce it much faster after 2030. but as long as we haven't exceeded, it's the total amount that we emit is the main thing, because CO2 is a very long-lived gas. So if by 2030 then we are, say, 30% reduced globally, we can still target 1.5 degrees centigrade. So the 2018 report, it said of the pathways they looked at, so it wasn't of all possible pathways, it was of the ones they looked at, and the ones that reduced by 45% to 50%, with quite a bit of leeway either way, by 45% by 2030, then those were the ones that achieved zero emissions by received 1.5 degrees centigrade. But always, of course, it could stay higher and then go down faster, or of course it could have gone down faster now. So if we reduce it down by 45%, for instance, by 2025, I mean a very unlikely thing, but suppose we did, then we could reach zero, who knows, maybe 2070 or something, I don't know the actual figure. So, and that's the way it works, it's the total that matters. So how quickly you have to reach zero depends on how quickly you reach halfway. And so basically, if we can reduce by 45% by 2030, then we can go down really very steadily from there to zero emissions. The last few percent are the hardest because we are left with things like aviation and then vehicles, the last few vehicles and things like that. And there'll be some industries that are difficult to change over. And but then we will have so much extra technology by then. And if you look at how much technology has changed from the year 2000 or year 1990 to 2020, think how much it changed from 1990 to 2020. I don't think we had mobile phones in 1990. I mean, not certainly very few people had them. 1990. What was it like in 1990? Trying to remember. That was when, I mean, back then we had these huge, the televisions back then, no flat screen televisions. They were huge things like that, this deep. Sure, you know, it was about the width of, you know, trying to get both my hands in. I mean, I wouldn't be able to get the width of a television, about the width of your shoulders was the depth of a television. And I think pretty sure back then they had these long aerials poking out of the and quite big chunky things, and you mainly saw them on TV, on movies, because most people didn't have them. And the computer screens for my first, I had a big gap. My first computing was done on mainframe computers, and then I had a big gap when I was doing maths. I didn't have a computer, and then I had another computer after that was one of these big things, and then I had a better one, and that had a really big, it's really heavy thing, very hard, quite a heavy thing to lift up, because I had a high resolution screen for my computer programming, and so that was quite a big one, and that is how much technology has changed in 30 years. And solar panels nobody had solar panels back then. They were things that you use on spacecraft. And you didn't have CCD cameras. That came in after that. You know, CCD cameras were immensely expensive things, again, used for telescopes and on and spacecraft. Very big astronomers' telescopes, not your amateur's telescope, but like an observatory. A big professional observatory would have a CCD camera. Immensely expensive things, not within the range of an amateur. I'm pretty sure that 1990 was before that. And as for gene sequencing, the first project, the year 2000, was, and I remember the news then in 2000 when they announced that they had sequenced the human genome for the first time, and so the first gene sequence, and now we think nothing of it, and then rapidly sequencing COVID-19 and so on. And in the year 2000, then that was absolutely impossible. And sequencing the human genome was an immense project, almost like a moonshot project, and it had huge rooms with lots and lots of workstations, all working on this big, difficult project of sequencing a single human genome, a single human gene sequence. And now people just send it off to the labs and they get it back. And so things have changed hugely, and that is just 20 years ago. So what is the technology going to be like 30 years from now, when we need to reach zero emissions? And there are many developments that can happen on that time scale. Like, for instance, synth fuel may well be economic well before then. There is the possibility of fusion power being economic by then. Nuclear fusion is, it could be small-scale nuclear fusion, that could be possible by 2050. And then, and that might be a complete game changer, or it might not. We don't. It's almost impossible to predict these things in advance. We never predicted mobile phones. Back then, it was thought impossible to have a mobile phone without a long antenna. And then they discovered fractal antennas. Every mobile phone has a little fractal in there. They discovered that if you make an antenna in the form of a fractal, then it can fit inside a mobile phone case, and it is just as good as one of those long, thin antennas. That was a discovery that they just didn't know in 1990. And so there's there will be many discoveries like that between now and 2050. We will have, may well have rice that has very much higher yields in warm temperatures based on corn, on maize. And then the batteries hugely improved. They may have lithium air batteries, which have the same power density as petroleum, or very close to. And that will mean long-haul flight can be battery driven. And I mean, those are just kind of very obvious things that we may well have by then, because they're not that far away. And so I think our main objective should be to, as they're saying, keep on track for a decent reduction by 2030, and then we don't need to worry too much about what we're doing by 2050, because who knows what technology we'll have then. If we can see a way to do it now, I don't think we need to work out detailed plans for what we do in 2050. We have plans of one way we can do it. But when it gets to 2030, we'll have lots of new technology. By 2040, we'll have vastly new technology, and what we actually do will probably be very different and much easier. So the real thing is to make sure we are going down now, because if we don't go down, and then by 2030, then they have a much harder job from 2030. They'll have to get to stay within 1.5 degrees C. Now, there's also a possibility of taking CO2 out of the atmosphere. There are many ways of doing it. In some ways, it can be commercial. And I think there's a good possibility, like the giant seaweed farms, like ways of improving soil, and then there's actual mechanical ways of doing it. And there's also the possibility of making limestone directly from the carbon dioxide in the atmosphere. The limestone made from the CO2 emissions from fossil fuel factories, fossil fuel power stations. But there could be a possibility of that actually from the atmosphere, of actually making products from the atmosphere. A synth fuel, perhaps the most obvious in the near future. No, I think there's a project that could use, yes, I remember writing about it. There's a project that you can make limestone from carbon dioxide in the atmosphere, along with certain other rocks and things. And not just the CO2 but mixed with other producing rocks, I think. Can't remember the details now. It's in my Dare to Hope blog post. And so we just don't know what we will be able to do in the 2030s or the 2040s for sure. So, but we already can see how to reach zero emissions by 2050. The United Kingdom is already committed to doing that, the EU, and that's based on technology we already have. So I think that's just an important thing to bear in mind. This is based on technology we already have, but we expect technology to improve hugely. We can already foresee, with a fair degree of confidence, a halving in the cost of renewables by 2025. And it could be faster than that. We had a threefold reduction in solar panels in the last 5 years. We could easily have another threefold reduction by 2025. That's not beyond the bounds of possibility. And it's already competitive with the least cost fossil fuels. Imagine if it's a third of the cost of the least cost fossil fuels by 2025. And then think what a difference that would make to countries being able to plan for reaching that 45% reduction by 2030. So there we are. That's me positive framing all this. So I hope you can see the value in positive framing. And if only journalists were to do that more, and they won't just do all this negative framing and not looking at the positive possibilities. They just ignore all the positive things we've done so far and all the positive possibilities for the future. And they just say, we're not doing anything, we can't do anything, nobody seems to be even trying. And it's just so far from the truth. So far, it's incredible. I mean, in 2015, I would never have guessed how much we would be doing in just 5 years later. And in 1990, what we're doing now would just seem like science fiction fantasy. It would seem like something out of Star Trek. If you'd explained what we're doing now to a geeky person in 1990, they would just wouldn't believe it. What we can do and what we are doing. And yet it seems so normal to us because we just lived through it, and it happens so slowly, even for older people like me. And each year there's not been a major change. But if you think back to 1990, never mind the 1960s, you know, when I was growing up as a child, in the 1960s, I watched Apollo going off into space. Back then the memory for the Apollo computers was hand woven, little iron cores, iron rings. And then the ladies back then, it tend to be women, did that work. They hand wove every single bit into the memory of the computer they sent to the moon. They just put fucking wires into these things by hand, into every single bit. I think it was every single bit or every byte, I'm not sure, of the actual computer. And there was someone actually putting an individual wire into that to make it work. And look where we've got to since then. Just step by step, little by little, every year. Each year looks like it's the same technology as the previous year. Just a few announcements that you barely pay attention to. But over 50 years, you look around and everything's completely changed. And so just think what it's going to be like in 2030, what we're going to be able to do in 2030. And so anyway, so hopefully this has helped giving you some positive side to understanding everything, understanding what's happening. I'll upload this now. It just reached an hour.